Hi, welcome back to my videos. My name is Mr. Brash. I'm going over as much math as I can on this YouTube channel. And today I'm going to be talking about a perpendicular bisector. So we need to describe these things to ourselves right now. Perpendicular. Now, hopefully you understand what that means and you've seen this before. So perpendicular means right angle or 90-degree angle. And this is sort of the math symbol for perpendicular. But have you seen bisector before? Now, in one of my other videos, I go over what a bisector is. It's this idea of cutting in half. So a bisector cuts something in half, cuts in half. And due to my handwriting, that looks like it says cats in half, but hopefully it's not cats in half, so cuts in half. Okay, so what's being cut in half here? So just have a couple tools up at the top here. When it comes to math, you really need to have some tools in your tool belt and then know which tools you need to pick out. But what's the question? Okay, the question is this. Given triangle RST, where R, S, and T are these points, and I've pre-graphed it on the right-hand side. So here's R, S, and T. So given those three vertices, determine the equation. So some flags are going off here. Determine the equation of the perpendicular bisector of line RT. Okay, so perpendicular bisector was already described to me. It's a perpendicular that cuts something in half. Equation means equation of a line, right? Because we're dealing with lines. And of RT, of line RT. So I'm just going to solidify for myself what that means. It means that I am going to find the bisector of RT. So it means cut in half. And it's pretty obvious that the halfway point is here, but we're going to prove that with math. And then the perpendicular bisector. So not just the item that cuts this line into two pieces, but the perpendicular one of it. So it's going to be something like this, or you know, something of the sort. That's not wonderful, but it'll have a 90-degree. It's not necessarily going to go through vertex S, and I can sort of tell, in fact, it's not. It's going to probably go just to the right of S. So we need to pick some tools from our tool belt. What do we know and what do we need to know? Well, I need this midpoint, that's for sure. So we go ahead and do that. Why wait? So I'm going to need the midpoint of RT. So I'll add my x's, I'll add my y's, and I'll divide each of those by 2. -3 plus 7 divided by 2 for the x's. -1 plus -3, so I'll just go ahead and subtract 3, divided by 2 for the y values. Okay, so 4 divided by 2 is 2, and -4 divided by 2 is -2. So in fact, I've proven that the midpoint is 2, -2. It might be obvious to you on the graph where the midpoint is, but you have to do it mathematically, because what if it was off by 0.1 or 0.01? You need those numeric values. Okay, great. I've got that midpoint, and maybe for now I don't really know why I got that midpoint. I also know that I need an equation of a line. Okay, so I need an equation of a line, a y equals mx plus b. Great. How do I get any of that information? S is useless to me. I'm not going to use that. I know that I could get the slope of, say, you know, R to M or M to T, or even all the way from R to T. Is that slope going to be helpful to me? Well, it is, because I need the perpendicular of that slope. Oh, okay. Well, I'll go ahead and I'll get the slope. I'll do the little sort of like cursive lowercase m here, not to get this, you know, screwed up with my midpoint here. So RT, so the slope of RT, we'll do our delta y over delta x. -3 take away -1, and 7 take away -3. -3 plus 1, -2. 7 plus 3 is 10. So my slope looks to be -1/5, and we can always check that by counting. Down 1 over 5, down 1 over 5. Yes, my slope is -1/5, and you always want to do it mathematically, not just by counting squares on the graph. But that's the slope of RT, and I'm so happy that I have that, but it's not what I need. I need the perpendicular slope. So you should already know how to do perpendicular slopes. Hopefully you do. A perpendicular slope, which I like to write as perpendicular slope like this, is going to be the negative reciprocal. So I'm going to change the sign on it, and I'm going to flip it. So this is the slope now of 5 over 1, or just the whole number 5. And it's positive. And it's going to go in a positive way. So up 5, 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5, and over 1. And so like I said, it's going to go just to the right of S. Just to the right of S. I'm really bad at freehand drawing something, but It's going to look like this, and that's my right angle line, and they want the equation of that. So I'm almost there because I've got that perpendicular slope. Let's continue with the yellow here. I've got that slope of 5. How do I get the y-intercept? And I mean, yeah, I could count, but I'm only lucky that my slope's a whole number. So let's do it mathematically. I need something that I can plug in to y and to x. And it can't be r, it can't be s, and it can't be t because they're not on that line. They're not on that yellow line. If they happened to be, then yay, I could use those. But the only point that I can use is my midpoint. That's the only one I can actually use here, is that m. So I'm going to plug in my y value of -2, my x value of +2, and I'll solve. So that'd be 10. I'll subtract 10 on both sides, and I get -12 for my y-intercept. And it kind of makes sense if I were to extend this line down, yeah, I'd probably get to about -12. And that means that my perpendicular bisector has the equation of y equals a slope of 5 and a y-intercept of -12. You might be wondering why perpendicular bisectors are important. I'm actually going to have another video that sort of shows why they're important and sometimes why we use them. But more so than why it's important, I mean, why does Johnny buy 72 watermelons, is this idea of using the tools you've been taught. So hopefully by now you know slope, perpendicular slope, midpoint of a line, distance equation. We're going to start to put those to use. It's not always about that exact question. It's sort of about that idea of problem solving and being able to get to the answer. All right, so that's it for this video. I hope you enjoyed it. Leave a comment, maybe subscribe, all of those wonderful things, and keep practicing math.